My name is Maria Mcsharry, and I'm a PhD candidate at the University of California, Berkeley. I work in the LaRoe lab where I study gene expression in yeast. The genome stores information, but it's also dynamic. It's involved in processes like gene expression that are going on all the time. This looks like DNA being transcribed into RNA, and then RNA being translated into protein. mRNA is decoded 3 nucleotides at a time. We call these nucleotide triplets codons. You can see in the chart that each amino acid is encoded by anywhere from 1 to 6 codons. A group of codons that encode the same amino acid are called synonymous codons. Like synonyms in language, synonymous codons are not necessarily equivalent. Codons decode at different speeds, and this can have an impact on protein abundance, protein folding, and protein function. I wanted to know whether we could detect an impact on the organism if we changed synonymous codons. To get at this question, I took an essential yeast gene that has 10 contiguous slow codons in the middle. It's rare to see so many slow codons in a row. Because of this, and because of previous research demonstrating that it interrupts the function of the protein, I hypothesized that I would be able to find an effect in the growth of yeast. You can see that in the complete SCD medium and in the minus trip medium, that the mutated biological replicates all grew slower than the wild-type yeast. My assay demonstrated that when you switch a codon, not only does it impact protein output, protein function, but that also it can be felt at the organismal level. These yeast weren't happy when I had changed the codons. Even though their protein had the same exact amino acids, when I swapped out the codon, they weren't growing as well. Typically, when you change a codon for its synonym, it doesn't cause problems in gene expression. Just like changing synonyms in language, the message is typically the same. But our assays have demonstrated that that's not always the case. What we don't know is, when does it matter when a codon is swapped? mRNA is already heavily used in research, and we're encountering it more in medicine every day. We can also use mRNAs in industry, and I'm thinking specifically of food production. So for this reason, I think it's important that we become even more fluent in the genetic language so that we can cleverly design mRNAs and get the most out of gene expression for these applications. I'd like to thank ARC's donors who are supporting scholars like me. We are at the forefront of discovery, and you're right there with us.